You glaze? I'm eternal glaze? What are you talking about, Umbra? Man. I didn't think this was gonna be this. I thought... Man. Fuck. This means I have to, like, think... I thought this was gonna be, like, the super easy stuff. Which we were doing in lecture. That's kind of sad. Oh wait, I didn't do them on engineering paper before, so I won't do them on engineering paper now. It's okay. It's not super hard. It's just combined stress states, I guess. Hi everybody. By the way, how's it going? It's just like, I don't really want to think about it, but we can do it. It's not going to be the worst ever. Okay. Alright. Oh no. Oh no, wait. Power transmission. Oh fuck. Okay. I thought it was a stress problem. Okay. We have to read. It's not even on the screen for you. Here we go. One of these days I'll get it so that it actually turns in space. Not today. A countershaft carrying two... Hi everybody. I hope everybody's doing well. Sorry for just like jumping in. Alright, a countershaft carrying two V-belt pulleys is shown in the figure. Pulley A receives power from a motor through a belt with the belt tension shown. The power is transmitted through the shaft and delivered to the belt on pulley B. Assume the belt tension on the loose side is 15% of the tension on the tight side. Use moment balance about X to determine the correct sense. What? Okay. So the belt's tension on the loose side at B is okay, no, okay. We're chilling. This is I see. So we're gonna do a moment about X. I got it. What the heck is going on in this Looney Tunes ass sound effects? Alright, we're gonna do moment about X. I guess moment about... Oh, X? Can I do that? Did I say that? Why is my music so loud? Get out of here. It's on 4% volume. Okay. So, we have... 300 pounds force times 8-inch diameter. 1-inch diameter, so 8 divided by 2 is 4. I don't need to add the 1 inch. I don't know why I thought I needed to. Why would it specify? That would be evil. Okay. 8 times 4, and then minus 50 pounds force times 4 inches. And then plus... Oh boy, okay, so T2 is in the positive direction, so plus T2 times 3 inches. And minus T1 times 3 inches. Now, T1, well, on the loose side. I don't know which one is the loose side. I guess we just... Which way would be the loose side? Does it matter? What do you think about that? Well, okay, it definitely matters because... because... You know... It's gonna change the stress state if it's different. But also, it doesn't really... I don't think it really matters that much, actually. Let's just say it doesn't matter. Wait, let me see. Yeah. Alright, well T1 is gonna equal 0.15. I'll say T2. The loose side. Well, if it's pulling... Wait, which way is the belt spinning? I guess this one is spinning this way, which means this would be spinning this way. Wait, it's delivered to the belt. So the shaft is spinning this way. So it's pulling on T2 and T1 is looser, I think. So T1 is looser than T2. We're gonna say that. There's some logic there. As this turns this way, this gets pulled. Maybe they both get pulled. I don't know. What do you want me to say? Okay. Where's my calculator? Oh, it's all the way over here. Oh my gosh, chat, I got a bag that goes on my bike, and it's so cool. And I'm so excited to use it, but I'm kind of scared because I haven't used it before. I feel like it's gonna fall off, which it won't. It won't fall off, but it's an unfounded fear. But you know, you're like, oh, like you're just like scared of it, because like, I don't know, that's just like how it is. But I'm so mad because I don't want to put my computer in it yet, because it can hold a computer. But I'm like, what if like my computer like blows up somehow? But I have to use my computer like every day, so I'm like trying to think about when I can like test run it without the computer, and I can't find any time. I'm so sad. Right, so this is negative 1,000 pound force inches. And then we've got T2, so T2 is the big one. So 3 inches times, it's 1,590, 85. Sorry, my calculations are a little wacky. So it's negative T, wait, what? That shouldn't happen. Wait, that shouldn't happen. Right? Didn't that not happen? But if it was the other way around... Oh, okay, so I see. It's telling us that T1 is the one that's getting... Bruh. Hurricane ran through chat. Oh god. Oh yeah. Wait, are you in Florida? Oh no. I hope you are staying safe. It wasn't even bad my power didn't go out. Oh. Well, I mean, if you aren't in like the evacuation zone, I'm assuming it's not as bad. But sheesh, it's not good. I would not want to be there. I'm not gonna lie. Let's see, 392. They got wrecked, yeah. Not good. You're so back? Wait, let's go. I'm so not back for thermo. You're probably like a million light years ahead of me. Oh, nice. Okay, T1 is... Yeah, okay. Sick. Been studying my ass off, I found the motivation. Nice! That's awesome. Wait, I got 156. Which, I mean, I guess if you round up... I'm not doing thermo right now. I'm gonna do thermo after this. But it's like, it's so stupid. It's actually so stupid. We're just doing like delta E equals Q minus W. Like physics 1 thermo. I'm gonna do 1/6. That makes more sense to me. And then T2 equals Q plus W. It just depends on your convention. we say that it's minus W because W is like positive W is out. And so if you want to account for the energy, then you have to... It's kind of silly. Is nasty work? It's not really that bad. It's kind of just like, if you think about the sign, then you don't really have to think about it. Convention should be Q plus W. Yeah, I think it's because we want to say like when we say delta E, if we're adding the Q, and then what do we do when we add work to it? It's negative work. Otherwise it would be if we had positive, yeah. It's just, I do kind of understand why they have the work positive is the work that is the good work, essentially. Like, we're not adding work to it, but it would be so much easier if it was positive. It should be. I think that's right. Yeah, 58.8. Nice. Alright. Find the components of the bearing reaction forces. Okay, that shouldn't be really too hard. I think I can just do a moment, and that'll probably solve my issues. Yeah. It really does all rely on the side of work AC. Yeah, I kind of don't... I don't know. I guess my sort of philosophy on it is, I think when you're doing sign stuff, if it's fluids or thermo or even dynamics, just make sure you know what it's doing and then properly account for all your stuff to be in the same direction. It doesn't really matter if you're like, oh, I need to make this work negative, positive, whatever. It's like, the sign doesn't really matter. Why do we use delta E instead of du? Well, our delta E equals the potential energy change, the kinetic energy change, and the internal energy change. And then usually this boils down to m times delta little u. Like that. So this thing, like on most of the problems, they say don't worry about those other two things. And just do that. Yeah. But it's sort of like we have to start with the first law. A lot of engineering, you know, like when we did fluids as well, it's like you start with conservation of mass, even if it like tells you something really simple, and then just cross out like every single thing in it, you know, and then I'm gonna do, I guess, this way first. Y, X. This is O, Y. And then this is 350. And that's that. And there's a component for C. CY. Moment about O equals. I could do this in 3D and then my life would be a little easier, but whatever. We're just gonna do this. 8 inches, I guess. Man, I did that wrong. There's some weird, I don't know, God, my professor was maybe the most boring lecture I've ever had last night, which is really impressive, I think, because generally if you're lecturing on something new, I feel like it's hard to make it super boring, because at least there's the newness of the material. But God, he started talking so quiet. He started talking like this at the beginning of the lecture, and then he started talking like this, and he was like, this and this and that. I was like, dude, people aren't even going to be hearing you right now. How is this? This is impossible. I'm gonna cry. It was so bad. 8 and 8 is 16. 22. Yeah, it's so Jover, you're so right. I'm gonna change the direction of CY real quick. I don't know why I drew it up. I mean, they always draw it up, so it's, you know, it's whatever. I don't think 27... Actually, yeah, O is gonna, and then OY is gonna be whatever else. I was gonna say, I don't think OY has a thing. It does have a thing. I don't know why I... That'll be negative. Negative. Or not negative. I guess I'll just draw it negative. 222. I don't know why I put so many decimals. I've been skipping all my classes and learning everything by myself. This is either the biggest mistake of my life or a massive Chad moment. It depends on how bad your professors are. My thermo class, wait a second, how many people are actually enrolled in my thermo class? I want to see this. Because I counted yesterday how many people, and I think there were legitimately 15 people in the lecture. This section has 1, 2, 3, 4, 5, 6, 7, 8, 9, 12, 13, 19, 25 people. No, sorry, 24 people, and only like half. Not half. Okay, it's a little more than half, but that's like kind of crazy. It's giving thermo transport and my coding. You should go to class. I do think one of the things that's nice about college is, you know, if you need to just take time to yourself for whatever reason, I think that it's really sometimes the better decision to take that time instead of trying to push yourself and like go to class like you might have to do in high school. But I also will say that I think you should go to class. I think I did low-key depressed. I'm just doing this all by myself. So small. There's 90 people in yours? Yeah, it is pretty small, but this guy isn't... He doesn't ask us any questions. He literally just talks. And it's a lecture that small. And he, like, doesn't do any problems. He like, you know how, like, I'm like, oh, this is what I'm doing here, like, we're going through this, I'm writing it. It would just be me, like, going, like, okay, so this is this, and this is this, and this is this, and here's the guiding equation. It's crazy. It's stupid. It's just, like, it's actually... Let's see, 392 plus... That is some number. He just writes random shit on the board. He doesn't even write it on the board. He just has it on pre... It's like I feel like when you're on a Twitch stream and somebody's like, this is pre-recorded, when they're clearly live. But it's like he's actually pre-recorded in real life. It's crazy. It's so straight out of textbook. Exactly. Exactly. I think we have the same professor. It's actually... I feel bad for the other people. No, okay. Thing was he was doing an example problem, right? And it was literally just this. It was delta E equals Q minus W, right? So it was the easiest thing ever. It was like mass times internal energy change. It was asking for the heat transfer. There's work in this problem. It was a volume expansion problem, and he just wrote this. And I went, oh, so where are you calculating the work? Because it was a polytropic thing, so it was like PV to like the 1.5 or something equals constant. And he was like, oh, I must have added it in there, and he didn't have this term at all. And I was like, so like where's the term? Like how do you calculate, like how did you calculate that? And he was like, oh, I think you just do like P times V1 minus V2 or whatever. And I was like, you literally don't do that. You literally don't do that. Why don't you denote the energy change as U hat when pulling mass out? Oh, yeah, we are supposed to do that. But he was like, I feel like as engineers, you just write it as small u. So like big U is the full internal energy, and then small u is the specific internal energy. Wait, so work here is negative PdV. Well, work here is the integral from V1 to V2 of PdV. So what you have to do for this is you have to solve P equals C over V, this one, And you can get this constant because they give you like the first pressure and that. And then you can find that. And then the heat going in or out of the system at constant pressure changes it. No, they're asking for the heat transfer rate. So they were they specified this as a value. I've never seen that P. Well, so this is a specific like process type. It's called like, I think it's called polytropic. This is just like a definition of like a pressure volume relationship. It's not it's not the same thing every time. You could have P be like, if you had P be a constant, then when you do this, then this would be P times the integral from V1 to V2 of dV, and then you would get P, you know, V2 minus V1. So if you had constant pressure the whole time, but we don't. We have a changing one. They make us integral the work integral. Integrate the work integral. Yeah, we just do that. But it's, if we don't have constant pressure, then this is a function of V. So we integrate this. So it would be work equals the integral of C over V1.5 dV from V1 to V2. Yeah. It's kind of similar. It's not really that similar to fluids, because in fluids you don't really have to do, when you're doing work stuff for fluids, I feel like it's more, it's a little later, and it's more about the work. You're going to be solving for the work through like mass flow, through whatever else. So it's not really, you don't really have to do an integral of a function, because that would be really strange to ask us for. Equals 0. So we have 450, and I guess that's negative. So this one's positive. Usually if pressure isn't constant, I'll choose a system in which there's no boundary disturbance. Yeah, we haven't even gotten to that part yet. We haven't talked about control volume choice. So, yippee! Jover, I know, it's like, it's slow. So, I mean, the other thing is that generally for MEs, it's not a requirement, but generally people take fluids 1 and thermo 1 at the same time. So it's a little different for me because I've taken fluids 1, and fluids 1 is more, basically like the more in-depth version of all of the stuff that we're doing, except with less focus on the air part of it, like pressure volume. So it's like you kind of learn it at the same time, but like from two different perspectives. So that's why it's so baby mode compared to the stuff that I was doing before. We just got to momentum transport. Oh my gosh, that's so fun though. I love I don't think momentum is the worst. I think that my least favorite was Navier-Stokes. Dude, cylindrical Navier-Stokes is the worst. I can't. I cannot deal with it. It's so grimy. It's like, it actually just looks like I spilled ink all over my page with how much like partials and all those crazy little things are. I hope this is right. CY equals 327 point, I guess 328. Please be right. CY. Oh no, I went out. Wait, that's practice problems. There we go. Oh, negative. Whoopsies. Oh wait, it is negative. Well, oh yeah, I guess. Yeah. No, I'm chilling. CY is negative. Uh-oh. It's not right. Check Discord, let me see. Newtonian fluid is in laminar flow, a narrow slit formed by two parallel walls distance 2b apart. Versus the b, so ed effects are unimportant. Differential momentum balance. Wait, that's not that bad. Wow, they got some fancy ass P's. What are those P's? What the heck? What? Oh, P equals P plus... Oh? P minus rho GZ? They just made something up, but they made like fancy P. P pressure plus rho GH is... That's kind of weird. I guess they're just taking out... Taking an entire 100 week to understand this ass homework, and I have quantum homework due next Thursday. I think the thing that, for me, made any kind of Reynolds transport equation very simple was just understanding, like, okay, you always do conservation of mass, and then you get that, and you're like, okay, what do I need to do next? Oh, I need to do, fuck, I don't even remember anymore. But like, oh, now I need to do angular momentum, or oh, now I need to do linear momentum in multiple directions. And then you just cross stuff out, and you kind of, like, my professor described it as like mass accounting, essentially, because you're not really doing, it's very, very formulaic after you choose your control volume. I have a midterm for my coding class, and I haven't done the last 4 homeworks, bro. Well, I have to do this, and it's due today, and I'm slacking right now. I hope they're not all this long. I don't know why. Wait, CZ. Oh, wait. Oh. Wait, we're chilling. I read OZ instead of CZ. That is CZ. Yeah, never mind. We're good. And then OZ equals... They called it something else. No, they didn't. They called it that. 123. I really want to get this done because I want to do my intermediate dynamics activity. It's such a fun thing. It's coding, but it's like fun. I want to do it with you, Chad. It'd be so fun. Instead of this, which is objectively quite bland. Draw the shear and bending moment diagrams for the shaft in both loading planes. Procrastinating so bad with this coding class. Wait, what is it? Is it just a generic, is it a CS class? Or is it an applied coding, or what's up with it? I'm gonna do the shear whatever in this, because I made the problem statement too big. Point of maximum bending, the normal bending stress and the torsional shear stress. I think I can do that. Numerical stuff? No! That's what I'm doing right now. It's so funny. It was so funny because we have to do Coriolis effect, which is a thing that happens when you have a rotating object and you throw something off of it. Essentially, it looks like it's curving, but it's actually going in a straight line. And we were all trying to do simulations for it, and ours looked so bad. They all look so stupid. It's really fun. I love it. I'm just like, it's fun because I feel like there's not a lot of ME where you just get to fuck around. And yeah, I don't know. What if I just drew this in 3D so I didn't have to like worry about it? I'm gonna do that. We're gonna draw it in 3D. I'll do it this way, which might be more confusing, but so this is X, this is Y, this is Z. I've heard of that. Yeah, my professor was like, I'm sorry, I don't have another example to give you guys, but like if you're a sniper, then you have to account for the Coriolis effect because the Earth is rotating as you try and shoot something. And she was like, linear regression in Python, but I have no clue what I'm doing because there's a bunch of random modules. Oh my god, yeah, it was so funny. Another professor wrote the module for our lab last week, and my instructor came in, he was like, guys, I don't know what's going on here. He has some stuff, I don't know why he's doing that. And we're like, oh great, yay, thank you. Okay, so for X and Y, we're gonna go down to 22. I just think it's kind of funny. I got a 40-second ad? Oh, that's fucked. That's actually fucked up. I was saying that my professor my lab professor, he's a graduate student, and he's like really good at writing. He's really good at writing the modules to be actually understandable and not bad. But another professor wrote one of ours last time, and he told us, he was like, I don't really know what this guy's doing. He's like, sorry. I think he did a typo in this line. Why did I say it was funny? I think it's funny that it's because like as engineers, like we don't get to mess up, you know? There's not a class where you get to just see your mistakes so clearly and see how you like fucked up physics. Like we had to do like problems about like, you know, modeling like a skydiver falling and then his parachute opening, and it's like, you know, he just like bounces on the ground like 5 million feet up into the air. It's like, that's not what's supposed to happen. I just think it's kind of funny. Okay, so then we go up 350. Wait, oh yeah, no, we're showing 127 is what it should be. It's kind of not to scale. Something like this, I think. You know, basically like that. I've been procrastinating so hard. I genuinely think this class is useless. I hate it here. You know, that's how I feel a lot of the time with a lot of the things that I have to do. Like, why do I have to do this again? I've been doing this for the past year and a half. I don't know why, but I'm doing it. So thanks, school. I don't need the review. I'm sure there are some people who need this review. I don't need it though. Oh wait, we're kind of... This is gonna... We're gonna do some artistry here. How big is O? Z? Oh, Z is 123. So like this. I'm gonna look at this, he's gonna be like, what the... Why did you do it this way? I'm lazy. I won't do it too then. 123 and then 450, 328. Okay. Don't worry about it, Chip. Don't worry about it. There we go. Perfectly understandable. Alright, I gotta go. I have to try and do these homeworks. Oh, good luck. I will be doing this, unfortunately. This is something. It is representative. Is it exactly what he wants? Probably not, but that's fine. Alright. At the point of maximum bending, determine the maximum bending? How do I know that? Oh, I didn't do the shear. Oh yeah, that would be helpful. How do I know that? This is V. Wait, this is C. V. I'm going so slowly today, chat. That, and then we'll just kind of... Wait, actually, before I move it, let me just put these here. Now we're chilling. Okay. So, 123 times 8 is going to be something. 984. So... say that. And then we go down 222 times, what was it, 22 minus 8, 14. Ooh, that's far. Wait, does that make sense? Wait, shouldn't it go back up? And then wait, what's the... Wait, no, wait. Wait. Trying to think. It should go back down, shouldn't it? Like, cause it's 123 times 8. And then we have 222 times... Yeah, what the heck? They're right, just the moment is not right. Wait, what if I try the other one? Oh, wait, because it's not 2... Wait, but that's worse. It's not 222, it's 382. What? What are we doing? What are we doing here? What's happening? I'm gonna get rid of that. Let me try the other one. Oh god, no. There we go. Let me try and... Let's do the other one. So 222. So that'll be times 16. And then 127 times 6. That's also not right. What am I goofing up here? I thought it's supposed to go back to 0. Right? Let me look at homework 1. That's more a circle. We need shear moment bending. So in ours, it would be, we go from, oops, look at this. We go from 0 to whatever's here. Oh, but it's kind of weird because, yeah, it should be, the thing at C needs to offset that, but we did say that it offset that, right? So it should be... Is it not 350? Wait, but... Oh... Is it 350 times 8? And then... down... But I think it's the... It's the area under this thing, though. Like, it should be 123 times 8 for Z. 123 times 8 minus the other thing. But that's way too big. Did I do my math wrong? I mean, possibly, yes. Because the max is 2111. Okay, so that's probably not... I didn't get that at all, so... But... Let's see, 123 is O... Oh, that's... No, that's O. So Oh, it's... No, that should be okay. Because it goes down, 123. Oh! That's in the Z direction. Never mind, we're okay. It goes away. 123, and then CZ, or then we do the T1, T2, which is minus 392.2 minus 58.8, and then C is, yeah. Oh. Yeah, and then C goes up. What? So it's right, but why is my bend? Why am I bending moments? Why am I not bending my moments? My brain's not turned on today. You know what? I'm just gonna do a different one. No, they're all... Fuck. I don't know, the quiz he gave was actually kind of pretty hard because it was really, there was a lot of stuff that he asked us to do in a pretty short amount of time. It's like 15-minute quizzes, and he asked us to do like all of that stuff, like all the Mohr circle stuff and everything. So it's like, ugh. Oh, interesting. Okay. Instead of a tire wrench made of brittle material requiring the inclusion of the stress concentration for the fillet at A, it is loaded with Fy equals 250 pounds, and okay, so just Fy, for a stress state in the small diameter of the small diameter of the shoulder at A. Determine the precise location of the critical tensile stress element. What is happening? Thank you for head pats. Chat, I don't know about this one. Chat, I don't know. Yawny Damie. I know, it's my I don't know what's going on, yawn. Let me get my notebook. Yeah. I think I remember because when we were talking about stress concentrations, it's like we need to go on the smaller side, I think. Maybe, or maybe on the bigger side. Wait, one of the two. Determine the what does he mean by that? Determine the precise location? Maybe, oh, maybe because there's a radius and we need to figure out, like, what the radius is, I guess? Like, okay, stress risers in geometry, shaft shoulder, cool. Huh. So none of that helps at all. I'm looking at my notes. At all. That's awesome. So maybe we draw this, I guess. Yeah, I'll draw it like this. So here's our fillet. And here's this. So where would our maximum, or where would our, I'll look at the slides. I think it's on the right for us. I'm gonna say that. That is going in on that. Stress concentrations. Okay. Oh. Well, oh. Well, yeah, okay. Use smaller cross-section for mass stress. Alright, I guess the critical tensile stress element, would it be, if this is a 1 inch diameter, this is 1 inch. We have this. Oh, it's a shaft. Okay, so the maximum stress is like here or whatever. Oh, I guess it depends on the loads. Okay, I see. So we have to draw the loads. So if we're trying to do that, if we move Fy, so we only have an Fy. If we move it here, we pick up, oh boy, we pick up a moment. I'm doing something with my hand. This is why it'd be awesome if I was a 3D VTuber. Pick up a moment this way. And then if we slide it this way with our moment, then we pick up a moment this way. So our stress state is going to look like this. Now, do I remember? I think because we have our force here, I think this is where A would be. Do I think it matters which direction? No. I don't think it matters which side, like if it's here or here. I think it just matters that it's like on this line, normal to the force. Because then our Q, our shear flow, I don't want to think about that. I don't know if that's actually necessary. But we do have this. How's it going, Scribble? Got a little X here. So this one is Fy. We picked up this one. This is Fy times 12 inches. And then this one is Fy times... We might need to convert it to feet. Is okay. What the heck? 9 plus 2 plus 2. No. 11. 9, 11. No. 11 inches. There we go. I think that's it. Oh. I guess. I don't know. I think that's where I'm gonna say that it is. Sketch the critical tensile stress element and determine the maximum normal and shear stresses at the fillet radius. Okay, sketch the critical tensile stress element. Done. Drown on Friday? I can drown. I have some water. I don't know what I'm supposed to do. Sketch the critical tensile stress element? What is... Determine the maximum normal and shear stresses at the fillet radius. Am I supposed to, like... I'm supposed to do shear flow? I really hope I'm not supposed to do shear flow. It might just be MC over I. I think that's what it is. So for the first one, it would be for the X one. Oh, multiple or more drowning Fridays. I'll keep drowning. Why look? Yeah. He says MC over I here. So it's probably a combined stress state, which we love combined stress states. I love it so much. Oh my gosh! Thank you for all the drowning Fridays. Oh, we're just keeping it going. Drowning Friday, Thursday. I'm gonna have to drink water this whole time. How are you so rich? Have you just been saving up for a giant Drowning Friday? Oh my god, they keep... I keep seeing them pop in at my activity monitor. Oh my god. Well, I hope you enjoy the hydration you're giving me right now. Hydrate. I drank like an entire thing of water just now. Very scientific measurement, a thing. All the professionals use that one. Draw the stress state? That can't be good. No, we're chilling. It's fine. I don't understand how it would be normal and shear. Because we don't have a normal and shear force. We only have, like, we have, you know, I'm probably gonna have to go. Aw, that's okay. I'm kind of not slaying right now. Let me see if I can figure out. Have a good stream. Thank you. Good luck on your projects. The numbers are not numbering. I might just, like, in lab, I might just work. You know what? That actually sounds like a good idea. Let me try the last one though. I might just collaborate with my friend in lab while we try to avoid having to use ANSYS. Oh, those are practice problems. Oh, wait. Maybe there's a practice problem that has a better example. No, that one's not really helpful. Also not really helpful. Inner torque, inner diameter, also not really helpful. Oh, here we go. Whoa. Oh. No, okay, it's okay, it's okay, it's okay. Wait. Why is it that? What the heck? Wait, chat, we gotta go on an adventure. So this is a different stress state. We only have one. We only have something like this. And they're trying to move this onto evaluate the likelihood of failure in section AB. So that he's probably trying to move it in here. So this one would pick up 2 moments, this one would pick up 1 moment. He has this tangent of moment z over moment y. Sigma bend equals mc over I. What the tau is coming from, I guess, so our moments create normal stresses, and then our forces create, well, this is a normal stress, and this is a shear stress. Wow, this is confusing. Hey, utility hook. That's cool. Woof, that was bad. Okay. So I might have to give up, chat. That might be the play. I'm not gonna lie. That might be kind of the move. I'm going to text my friend and say, hey, so what if we worked on the there we go. It's all good, mate. Yeah, I don't know. I think it's just like the examples that we did were a lot more straightforward than these, so it's kind of scuffed. I don't like it when professors do that. It's like, there's a... Oops, that was my tablet. I meant to do this one. There we go. There's like a level of that you can do, I feel like. But this is not... Brain is not braining. I want to finish the thermo also, so I don't have to worry about that tomorrow. So I'm gonna do thermo. I don't have to lie, I've just been thinking about that intermediate dynamics. I really want to do it. It's so much more fun than this. Wait, did I even write an answer for A? Oh, no, okay, wait. I was gonna take a picture of my answer for B, which we did. That was the, cumulative trapezoid function. Or, the cumulative, or just the trapezoid function. Traps. Where is this? This was in thermo. Thermo. There we go. I'm gonna take a sec to open it. I just want to take a picture of my code and put it in here because I don't think they will like me just saying, well, teehee, I got the answer. I don't know why it overestimates. Compare the different methods for estimating the work. Why are they estimates? Well, actually, I don't know why B is an estimate. Oh, okay, well, B is an estimate because we fit a curve to it. We'll just say D here. D is an estimate because PV 1.5 is curve fit, not an actual. D is an estimate because the trapezoid function isn't. I mean, yeah, it's not a continuous data. Because our data isn't infinitely continuous. I'll say something like that. We also only have 6 data points, so I feel like that's a fair thing to say. Let me run this. I could have just used the other one, trapezoid, but that's fine. Actually, it'd probably be better to do trapezoid. Let me make sure that works still. Yeah, I feel like that's just a nicer. I don't wanna subject anyone to having to realize that that's a function in MATLAB. I think now that I've gotten a taste of, oh my gosh, I can actually code stuff for engineering and I don't have to do it all by hand, I'm kind of like, oh my gosh, I really want to like get good at that, because I feel like doing the hand calcs is, we've been doing it for a couple years now, and it's like, I want to just, it'd be so cool if I could get better at the other stuff. 6.65 joules, kilojoules. Cool, that's all good. And then 30 and 33 we need to do as well. So let's see what that is. Maybe I'll come back to the other one, but my brain was not braining, so. Which does not bode well for my my quiz tomorrow, which I'm assuming is going to be a combined stress state question. I asked him, I said, oh, so like, is it going to be on stress concentrations or pressure vessels or something? He was like, it could be anything. Like, thanks. They're all really different and take really different amounts of time, but that's sure. Okay. It's very similar to the one that we're doing right now. Very crunchy image, sorry, chat. Yeah, I know, I don't need to know exactly what's on like a quiz or something. I think that's kind of silly, but it is kind of nice to know when you have a bunch of really disconnected stuff, kind of where you might end up, because, I don't know, these classes tend to be really all over the place in terms of the content, I think. They're all under the same branch of mechanics, but wildly different equations, wildly different. It's a lot of plugging in numbers to various equations, but. Alright, closed system consisting of 1.5 pounds of air undergoes a polytropic process, so we're going to have EV to the N equals constant. From P1 to V1, or from P1 to that, determine the amount of energy transferred by work in BTU for the process. That's fine. We can start that. Okay, the 1.5 pounds is probably for a BTU conversion, but maybe not. Work is going to equal the integral from V1 to V2 of P dV equals V1 to V2. We have V, then we're going to do, or sorry, we have P, we're going to have that constant. I'll just put C for now, over V to the N dV. So C equals, if we start out, wait, how do we get N? Wait, shit. Oh, they tell us, okay. Whew. So we do 80 times 4 to the N equals 20 times 11 to the N. And then we can When's your break for art time? What, like doing art? I don't have time to do art these days. Well, I was trying to do Productober, and then I realized that I have to, like, do life, and I can't do that, unfortunately. I don't like doing it this way as much. It's kind of confusing to me. I'm gonna do it the other way. I know, it's kind of sad. But it's also like, I'm trying to do a little bit less stuff because genuinely this quarter is awful for me. It's like, I'm basically in meetings or streaming or in class or sleeping or eating. I have like no downtime, or if I do, it's like 1 to 2 hours because I have class. My class starts at 10 a.m. I'll get up at like 7:30 usually, and like, you know, I can do a bit of stuff in here, but I have to leave, you know, by like 9:30 or whatever. And so it's like 10 a.m. all the way to 7 p.m. most days, or 8 p.m. And then when I get home, it's like, okay, I'm eating, and that's like 9 p.m. And then these days I've been going to bed at like 10 p.m. So it's like I have no time to do anything. And then on weekends, it's usually 10 to 12, 10 to 2 on Saturdays. And then I have this time, which is actually free to do life things. And then on Sundays, I stream for a certain amount of time, which is usually, well, it's going to be a little earlier. And then I have like 4 to 7 a thing. So it's like, this is the only time. This, and then Tuesdays I only have one class from 6 to 7, but I stream. So Tuesdays are the only days where I actually have like a day off, basically. It's a little scuffed. Oh, head pats, thank you. It's just really tiring, honestly. I wish I did not do that, but I just do a lot of shit, and unfortunately doing a lot of shit is really fun, but it makes you really busy. If only you were freer. I was having so much fun arting with mold a couple times. Yeah, that would be fun. The engineer, like, also a lot of my classes are just insane on the times that they have work due. It's like every single day I have stuff due. Thermo gives me 3 assignments a week. Strength and stiff gives me an assignment today. My labs are due before the labs, so I think the only day I don't have anything to do is Tuesday, usually. But yeah, it's kind of stupid. W equals v1 to v2, so in our case, that's good. Well, I can just integrate this real quick. So 1.37 times, that's vn minus, wait, shit, v negative n. The engineering moves are coming to life, yeah, n plus 1 over negative n plus 1, yeah. I think that's right. And then we just plug in our 2 different V's, and then the BTU I think is... I don't like that we didn't use the 14.5 pounds of air, but that might be because of the BTU. I'm not actually sure about that. Did we use everything? I think so. Times V1 is 11, or 4 foot cubed per pound feet, and then 11. So 11 foot cubed per pound to the negative 1.3. Oh, this is not right. This should be a constant. Oh, that's what we didn't do. C equals C equals, I don't know, what was the first one? 80 times 4. I mean, I do like streaming because I think that it's very calming for me. It's very... Wow, that's a big constant. It not only gives me a place to have fun with a lot of this stuff, which is not particularly shared around some of the people that I'm around, but it, you know, it just lets me have a time to work where I'm not... Oh, I can bring this out. Where I'm not really distracted. Because when I work on my own, I tend to get pretty distracted. And there's no like secret sauce to the not being distracted, unfortunately. It's just how it is sometimes. Oh yeah, and Stucky, because what do you do? You don't do like work on your streams, but do you do like stuff you could do in your free time, but you do it on stream instead, kind of things? Pretty much, yeah. Kind of. Oh, okay. What unit is this? It's foot-pounds cubed, but it's a weird number. Does that still count as foot-pounds cubed? Like... I don't know, because the other stuff is all constant, so it's not gonna have a value. We were given volume in... Oh, wait. Oh, that's why. It's feet cubed per pound, so that's a strange way of writing it. A lot of priority number 2 things, stuff that I should do but isn't urgent, so it's similarly... Yeah, a way to keep up. Yeah, that's... Yeah. That's real as fuck. Okay, I might have goofed this up. No, do I have to redo the whole thing? I definitely do. Fuck! I should do my volume conversions first. 4 foot-pounds per... foot cube per pound times... Why would they specify it like that? Ooh. Ooh. Ah! Who in their mind would do this? 58 feet cubed, and then 11 times 14.5. 159.5 cubed. Now I have to change all of them. Man. Wait, it should be the same ratio though, right? Wait a second. Wait, I'm kind of cooking. Wait, 4 divided by 11 versus 58 divided by 159.5 is the same number. Never mind. We're so smart, chat. I'm gonna say simplifies. I'm big brain. I did it on purpose. You didn't even need to worry about it. I still don't understand what the hell these units... Well, I guess it's gonna be in joules. It should be in joules, but like... How is it in joules? Maybe because my constants actually have units. Wait, yeah. Yeah, my constants are gonna have units that do stuff to this. Okay, well, whatever. 159.5 and then 58. Okay, let's try that. wait, the other one, this one's wrong. This constant is also wrong. Because this should be... what should it be? 58 to the 1.37. Okay. 80 times 58 to the 1.37 is big number. 20844. Yeah, I don't need to write the other bits of it. Okay, now we can finally get comfy in these numbers. Let's see. Negative 0.10 and 159 to the 0. Whoa. Oh. Fine. My calculator is not particularly happy with me. Alright, there we go, and then 1.9.52. Actually getting kind of cold out here at night, and it kind of caught me off guard. I was like, oh shoot. I biked back and I was like, wow, it's kind of a little cold. And then I got home and I was like, wow, it's so nice and warm. And that was nice. It finally is starting to feel like fall, even though it's already like, it's already like halfway through October. Ugh. 0.5 joules. And then I guess we do joules to BTU. Is that how you do that? I don't know. Let's see. Joules to BTU. Ugh. Divide the energy. Oh, that's approximate. Why does it look so weird? Wait, maybe I have a better version of it in my handout, my fluids handout. What? Wait, where did it go? Wait, where did it... What? Oh, I hit it. Oh, I hit it so it was easier to take out. The truck sound? Is there a truck sound? What? There's a unit conversion here somewhere that I don't know. Oh wait, should we... Wait, uh-oh. There's a helicopter. There was a helicopter. Uh-oh. Wait, BTU... Oh no, BTU per hour. Okay. 1 watt, we want energy. 1 BTU equals 10... Oh. 1055 joules. Okay. So then this joules times 1 over 1055 joules, 1 BTU equals... Nice. I mean, is it right? I don't know, but it's a number, and we're gonna leave it at that. I just divided by 1,000, not 1,055. Whoops. 3.71 BTU. British thermal units. There we go. Cool. So that was 30, and then we just have to do 33. And then we're home. We're in the home stretch chat. This is a long problem I'm looking at. Oh no, maybe we can get good. Okay, I kinda goofed it in the last one. I goofed it really, really quite incredibly, but it's okay. Yeah, so... We gotta do PV. The easy part we can do, I mean, it's not really too hard, but, alright, so, expansion, so carbon monoxide contained within a piston cylinder assembly undergoes 3 processes in series. Expansion from 5 bar, 0.2 meters, to 1 meter. Let me just look. Okay, so it seems like 1 meters sort of are 0.5. and 5 bar, and then we have 5 bar again. Oh, and evaluate the work? No! No! That's sad. Okay. It's fine. That's fine. Well, I'll do 1, 2... So 0.2 of 5, 2v equals 1. So pressure volume relationship is PV equals constant. So when we do 0.2 times 5, then we get 1. So then if we have 1, then the pressure is 0. No, is it 1? I think it's 1. Okay, so let's see, PV equals C. So 5 times 0.2 equals 1. And that equals P times 1. Yeah, okay, it's 1. I don't know why I thought it was 0. Whoopsies. Now let's just do 1 in the middle. So if we do P times, let's say that we're at 0.5. If it's 0.5, then we do 1 divided by 0.5. So 2. Right there. And then if we have like 1 divided by, I don't know, 0.3, then it's 3. Okay. 3.3. Sort of like that. So we've got this little curve here. And we can integrate that and everything will be great. So that's 1 to 2. Constant volume heating from state 2 to state 3, where P equals 5 bar. P3 equals 5 bar. Here. And then, okay, cool, there we go. That works out. Draw a straight line backwards. Let's draw it forwards. Nice. Okay, the easiest... Well, this isn't going to be too bad. The only thing we need to figure out is 1 to 2, really, and we just integrate that, and then the other ones we can just kind of subtract stuff or just 0. So, alright, let's do this. So the work from 1 to 2, wow, that's a bad arrow, 1 to 2 equals V1, V2, dV equals, our initial volume was 0.2, our final volume is 1, and our pressure is going to be V over C. I lied, C over V. Our constant in this case is 1, so that's no biggie. Is it gonna be a log? Oh, is it a log? Whoa. Yeah, 1 over V is a... Am I stupid? Wait a second, let me think. Integral of 1 over V? Am I good with that? Yeah, it's ln, okay. Whew. So ln of V from 0.2 to 1 equals ln 1. There we go. Work 1 to 2 equals something. .6 joules is my V in meters cubed. Yes, we're good. So let's put that there. Work 2 to 3 equals 0. Work 3 to 1 equals, we have 5 times 5 times 1 meter minus 0.2 meters. equals 5 times 0 0.8. 4. And this is minus work 1 to 2. Actually, is that true? Is it just the area? No, it's not. I don't think it's minus that. I think that's the total. I think the area contained within it is the total delta E or something. The total work. I don't know. I don't remember. Just say 4 joules. Because then it's like, we give it, it's like, if it's counterclockwise, then the work is positive or something like that. It's been a long time since Physics 2, and we did not do this very much. So, we're gonna do our best. Let's see, can you see all my answers? Yeah, you can see all my answers. Cool. Yay, that's done. Yippee. Okay, now, I could either go and do more strength and stiffness. Ooh. sorry. I'm gonna do a little bit of MATLAB, and then I'm gonna come back to strength and stiffness, I think, is what I'm gonna do. That's the wrong thing. Turn it off, turn that off. Then, what am I doing? This is why I need to not have this on this. This needs to be on something else. That needs to be on that. There we go. This is what I want to do. I think it's gonna be fun. I need to clear. How do I clear easily? Can I just run clear? It didn't work very well. Okay, well, whatever. I'm just gonna run it. So this is what we have so far. A lot of things are wrong about this. So we're doing the Coriolis effect. And we're trying to plot this with respect to a non-rotating coordinate system. You know, okay, I might need to redo this. Because, so what I did was, I rewrote some of this. Oh, chat, we might be cooked. Okay. Let me close this real quick and reopen this. I'm gonna rename it something else. Because I think I actually fucked up. Because I did rotation matrix stuff on that, and I didn't. I was like, this is the better way to do this. But I think they wanted us to do it without it first. I'm gonna say better, and then I'm gonna download the template again, and we're gonna go through it. Because it was just so bad, and I was like, this is an awful way to do this, and he didn't use any vectors. He like split everything up into X and Y. I was like, just have a vector, please. Oh wait, it's like hidden somewhere in here. Where? There we go. Alright, I'm yapping. There. I just gotta move it into the right place. There. And there. Okay. So, some of this stuff we can copy from this. Oh god, he didn't even put... Okay. Didn't even put semicolons. I see how it is. Wow, it didn't copy it. Thanks. Thanks, MATLAB. There we go. Let me make sure it's negative. Yeah, it's negative. Okay. T final is 1. R is 1. I know this. And then the V is weird. Throw speed relative to the merry-go-round. Here's this. Okay. So yeah, we're standing on a merry-go-round, we're gonna throw a ball. Person A is a blue star, person B is a black cross, ball is a red circle. And we have black axes and blue axes. So dt is 0.01. D is... yeah, this is all stuff that I didn't change. I guess I don't technically need these here. Alright, the initial position of the ball is going to be -r. And the initial y position is going to be 0. Alright. If we run this now, it's going to probably break somewhere. Oh, yep. Okay, that's fine. This is the velocity of the ball measured in the fixed frame at the instance t1. Make sure this quantity is a 3×1 vector. The ball's velocity is not going to change, so this doesn't actually matter. I'm going to get rid of it. I believe the ball's velocity doesn't... yeah, it's okay. Why did he not put a semicolon there? Sorry. Here we go. Too many spaces between comments. For simplicity, alright, so xi is going to be... Wait, he just... Oh, I see. Wow. There we go, that's what this is. Euler integration, real simple. Now, this is not exactly true because we need the component of the velocity. So it's going to be VA is, if we look at VA, it's got two components, so we want to say VA1 and then VA2. And if we had a 2D matrix, then we would say like VA11 or VA12. Now this is where I changed things. First off, I don't know why X is not first. So I'm going to change that. I'm going to change that. I also don't know why A is not first. I'm going to change that. Easy. That's not really useful though. So the position of X and Y, I just like rotated them with a matrix because I was like, we have an omega and we can just use the omega to make a rotating matrix and then do it. But if we say that we can say the X position of the person is going to be, we still need an omega. We're going to be using I. If we say I times probably some cosine of what? Well, we want to basically be stepping in the code. Let me think. Cosine I mean, if we have a triangle that's depending on omega, which isn't, the omega isn't going to change though, is the thing, but it's I times it. But if omega is always negative, then it might kind of mess this up, but I'm going to say cosine of, well, I guess we don't really need the, I guess it would be omega, well, omega dt is our little thing. And then times the radius, I guess. And then this would be sine. But this doesn't change where the person, this doesn't have anything where the person starts. I guess we'd want to say their initial location. Which we have no initial location for them, so we just are going to say that their initial location is -1 plus this, and this is going to be 0. And then for B, it's gonna be kind of similar, I think. But I don't know, this might not work. This will be 0. And the other one will be 1. It starts up. Let's see if that works. Let's see if it does something. No, well it breaks. That's awesome. It also starts at 0, 0? Why is it doing that? Why is it starting at 1, 1? Plot XB, YB. Wait, which one is person B? B is a black cross. Black cross should be at the top. I don't know why they keep doing B first and not A first, so I'm gonna change that because I'm getting confused. That's wrong, but it might be because, yeah, so fill in here. Make a plot of the 2 axes. I don't really need to do that right now. Oops. We can do that later, and then this one we can also do later. Let's just see if this works. And then I'm gonna, I'll put a break there. Okay, so, that's not good. Definitely not correct. So this bit is incorrect, for sure. But they are moving, so that's good. Plotting a circle, we would do x squared, y squared, but that's not super useful. What's the parametric equation of a circle? Let's see. R cos theta, R sine theta. Wait, that's what we did. Oh, yeah, wait, that's literally what we did. What the flip? What if I got rid of the 1? But that shouldn't, like, change it. Maybe it's because there's an I? Maybe it should be omit like this instead. Like that. Because then we're changing the sign. Wait, yes, wait, that might be it. But I don't know if that's gonna change this like actual. Oh wait, no, that should be okay actually. Wait a second. Wait, I believe. Why? What the heck? Here we go. Oh, they're doing something. Not where they need to be though. Why is it started 0, 0? What? 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 Why is XA start at 0? It should start at -1. Hello? Is position... Do we use position ever? No, he like doesn't plot position, does he? He doesn't. What? Wait, is it used somewhere? Doesn't look like it's used somewhere. What? What? I mean, I guess I could just say like that one equals position 1, position 2, but that's not really useful. Why is it not? I don't know why it's not starting at... They are moving in a circle, but they're not starting at the right places. This was happening in my other one as well, where it's starting right now. XA is... Oh wait, I guess I can't see. Maybe if... Let's do this. Let's just add all of the x's into an array so that we can... I'll just call this like x, or I'll call this a check equals, or a check I plus 1. No, a check I equals... Oh shoot, it's like I, comma, that. Then we add XA, XB. No, XA, sorry, YA. You don't print it out. So we'll do that, and then do the same thing here. B check, but XB, YB, just so we can see what is going on there. As long as it doesn't break, it doesn't look like it broke. So A check, we start at zero, zero. Why? So why? Why do we start at 0, 0? I have it set as -1 plus. Oh. Cosine of I. This might be canceling it out. So that's definitely an issue. Maybe I need to. Oh, it might be that I need to offset the. Okay, wait a second. Get rid of this. We need to offset the cosine to start at a certain point. That's what it is. So get rid of this. I see. So now, yeah, now they're both moving there, and they both, where do they both start? They both start over here. So we have to say x, xa. I guess we just add both, plus, what's it called? Plus 180, so pi. And then this one plus pi. And let's see if that fixes one of them. Yeah. Okay. Okay, we got it. And then plus 2/3 pi. That probably doesn't work. 3 pi over 2. Same thing here. Alright, now we don't need these other check variables. Yeah, because I was changing the origin, basically. Oh? Wait, 3 pi over 2, or should it be 5 pi? 5 pi over 2. There we go. Okay, so that's also really interesting because mine crosses this here, and that's correct. And other people were saying theirs wasn't crossing. Like, it wasn't able to... They weren't able to, quote-unquote, like, catch the ball. That's very interesting that mine is, like... That looks like actually perfect. And on this one, I think the issue is that I have... There's a lot of issues. I don't really want to think about it. I think for this, we just have a very similar thing for the quiver. So we're going to do a quiver... We start at 0, 0. Now, yeah. And then we just say that this thing is the thing, you know? Yeah. We say this one is this, except we don't offset it by pi, because we want that to start at the x-axis. Oh, I guess that's just, wait, this is just the x-axis. I'm going to say 1, 0. I'll make it, like, I guess, look good. I don't like that his comments are there. I'd like them to be above, whatever. 0, 0, 0, 1. My 2 little arrows. I guess I can do dash black for them to be black. I think that'll make them black. Maybe, I don't know. And then... Bruh. Yeah. I can't believe it. I don't believe it. I can't believe it. Oh, I probably asked for a certain line width. Whatever, we'll figure it out. And then these, we'll change this to this. The way that somebody else did it was like they set a scale, and I was like, I feel like that's not what I'm gonna do. And I guess I'm not doing that. So let's just see if one of them moves. And then I'll get rid of this one for now. Extra, there's a semicolon. Don't put a semicolon. Okay. Let's see. Why is that? Oh my gosh. There we go. We did it. Okay, that's awesome. So this is dash K. I forgot. It's not dash B. B's for blue. I don't know how to set line width. That's easy to look up. That's kind of awesome. And then we just do this for the other one. But we do an offset of minus 90, minus pi. Oh, don't do it there. I think this will let it work. Oh, no, minus pi over 2, sorry. My B. Oh, I see, line with equals 2. That's how we do it. Oh my gosh, oh my gosh. Winning chat, what is happening? Stop, don't put anything, don't do that. Oh, it's not, oh. Plus pi over 2? Wait, why, what? No, don't do that. So sexy, haha. Why is it slightly off? It's weird. I don't know, whatever. I guess plus pi over 2 then? Want to go the other way. There we go. And just like that. Wow, and he catches the ball. Nice. Okay. So yeah, this was the hard part. Because I was doing it with a rotation. So let me show you guys what I did. I basically said, okay, this is like the next part. I just did it because I was like, this is better. I made a normalized omega, and so I didn't have to type it out the whole time. I made a rotation matrix for that omega. Then I started a position. I also kept track of all the positions, which I don't actually need to do. So that was a little funky, but it's because I was rotating it. So it's like I kind of need to keep track of it, but I could keep track of it and then kind of like overwrite it, I guess. I don't know. I think if I did this times I or something, like if I did the same like cosine, if I did something like this essentially, then I don't think I would need to keep track of all of them, but I did. So then I just rotated it instead, but mine looks like this. Because this guy's out here. I don't know why he's out there. I don't really know how that happened. So, but hey, we got it to work. That is pretty nice. The line width 2 we gotta change, I guess. I think these are also supposed to be line width 2. Yeah. Blue color and line width 2, and the other one was, let's see, I didn't delete it here. Black color and line width 2. How does it look? Looks pretty good to me. It looks pretty poggers, honestly. Okay. Now we do part 2b, analysis and the rotating frame, method 1. Here we study the motion of the ball from the perspective of an observer rotating with the merry-go-round. For the first study, we simply find the location of a ball as a function of time by utilizing our xt and yt from part A and multiplying these results. Okay, cool, I did that. Find an expression for theta. So theta is omega. That's like omega times dt, I think. There's an I times theta dt. Position rotating. Find the position of a ball as a vector in this moment. Use what you have learned about rotation matrices to your advantage. Alright, this is gonna be, I think it's like omega crossed with R. So that would be like omega crossed with position. But no, that can't be it. I guess the velocity isn't changing. The velocity is still VA. We're just rotating it by omega. Yeah? So I'm gonna take this. Where's my rotation matrix that I made? Here we go. It doesn't really need to be 3D, but I made it anyway. This is called theta instead. And then we need to multiply by VA. I think that's... Wait, that's the position of the ball. What? I just made the velocity rotate. That's not what I need to do. The position of the ball? Well, but isn't it, like, changing? We can't use xt and yt because we overwrote them the whole time, right? Or do we have a... Oh, wait, no. Wait, this is fine. This is just, like, dot multiplied by... Bruh. Oh, no. It's like... No, it's okay. I'm really thinking. X, Y, Z, 0. But it's X, I, Y, I think. Does it need to be like that? I don't know. I think so. I think it needs to be like that. And then X rotating I. This is very easy. Position rotating. I, 1. Again, no semicolons anywhere to be seen. 2. Indicate the locations of person A and B is measured by the rotating frame. Okay, if it's by the rotating frame, then as we rotate, let's take a look. Let's steal this. As we rotate, this is always going to be the same, this is always going to be the same. Maybe easy peasy. So X rotating is always going to be -1. Y rotating of A is always going to be 0. This one's always going to be 0. And this one's always going to be +1. Make a plot of the X and Y axis at this time. Let's just make sure that everything else works first. I'm gonna run the first thing first, but then I'll run this one. I just want to run it once, and then I think we can just not really bother. Oh, awesome. I have an error. Okay, what? Unrecognized. He has an error in his code? Bro, X. Incorrect dimensions. Slay. I don't know what to say. This would be... This should be a 3x3 times a 3x1, which would give you a 3x1. I don't know, man. I don't know where my matrix is wrong. Fuck. I thought I looked at this and it was fine. God damn it. Incorrect dimensions. Is xi not... Yeah, I equals 1. Yeah, it shouldn't be an issue. Oh wait, these are columns. That's why. Not commas, semicolons. Okay, run section. Okay. Oh! Wait, we kind of cooked. Wait a second, they're like not moving. So Make a plot of the x and y axes. Oh, the little x and y. Okay, so these ones are not going to be rotating, and these ones are going to be rotating, is the thing. So I think we low-key just switch them. Wait, no. The angle of rotation of the merry-go-round XYZ to the fixed frame XYZ. In terms, yeah, our XYZ is going to be rotating because essentially we are looking at, we're on the thing, so we don't look like we're rotating. So it's going to be the color difference. So this one is going to be blue. And the other one's going to be K. Black. Oh. What do we think? Did we cook? Did we cook? Maybe. I don't know. Try that. I copied the wrong thing. This. It's gonna be black. Now, I don't know if they're gonna look exactly right from the beginning. We might have to adjust the rotation. I hit run, not run section. Oh my god. No, don't do it again. I think that's right. Let me think. In this one, blue is below these axes, X is above. Blue is, whoa. No, they're going the wrong way, I think. Because it starts, like, it goes in between the two. And in this one, it goes not in between the two. So it's rotating the wrong way. It should be rotating negative that. So I think I say negative? Or do I make omega negative? What do we think? What do we think? What do we think? Should omega... I mean, if we say omega's negative, it doesn't really make any sense. It's just that these fixed axes are rotating the other way. You know? You catch my drift? This is gonna do the same thing. Because they're rotating away, and we're sort of... Yeah. This is right. This is right. I think. Maybe. I don't know. Okay, wait, if you were looking at this thing here, at the black, it would look like those axes are moving towards you. You know, it's kind of weird, like, if you look at it, like, it kind of, like, if you imagine you're in the rotating axis, it does kind of look like it's rotating, doesn't it? Like, a little bit. I mean, it doesn't, but it kind of does. It's weird. Funky. Oh, there's an issue here. Okay. I am going to... Ooh. I'm going to end here, because I'm really... Oh, shit. I'm too sleepy. And I should eat some food. It was a short stream day, but yeah, I need to, like, lock in on this strength homework, too, so... I will see you guys... There's a possibility I might stream Saturday, but I might not, so it just kind of depends on what I'm doing, honestly. If I'm, like, really... if I really need to, I will, but I probably won't. I might just do the stuff I was gonna do off stream, so. But, you know, it's fun to do stuff with you guys, so. Alright, I will see you guys later. Thanks everybody for hanging out. Sorry for being so eepy, but, you know, sometimes days are just eepy. Warm out. It's afternoon nap hour. Alright, I'll see you guys Sunday.